Hello and welcome everyone to my channel Code with Ease by Varsha. So we are doing solid principles and we are going to discuss the I of solid today, which is interface segregation principle. So what we can see in this picture is there's a TV remote which is trying to control the TV. Remote in this case is being given as an example of an interface or an abstraction. Why? Because we know that it is a plastic case with certain buttons on it. We don't know internal wire circuitry of anything. But we know that by using this particular device, we can control the channels of the TV, the volume up and down, mute, and all sort of different functionalities. So now what interface segregation principle tries to say that always have small and focused interfaces. What it means, now let's say I have a TV remote. Now I also want to control the fan and the tube light of my room, and I will put all the bunch of buttons on this remote itself to control my home devices. Okay. I want to control the temperature of my AC also. Anything related to AC also, I'm going to put it in this remote. So from this remote of a TV remote, I'm adding bunch of functionality to control my home devices and then bunch of functionality to just for AC. So I keep on adding my functionality to this remote and the remote size gets bigger. What is going to happen now? In addition to controlling the TV, I'm also controlling my home devices and everything with this with this remote. This is not allowed. This is a violation of the interface segregation principle because my remote is now no longer a small focused interface. I have unrelated functionality on my remote, and that is not a good practice to do, because if I want to handle TV, why do I need the buttons to handle AC or any home device on that same remote? I can have a separate remote for that. So that is what these two terms are trying to say: small and focused interface. Have one remote for your TV, have one remote for your AC, maybe have another remote for your other home devices and all of that. So every interface or every remote will serve a specific functionality and it will be focused to that functionality only. And if it is not, if anywhere you find a mix of functionality in certain interface, try to break it down, try to separate it out. It is kind of similar to the single responsibility, where we say that each module or every class will have only one single responsibility. It is kind of similar to that, but the main highlight of this principle is to segregate the functionality. You have a big fat interface somewhere, you have to break it down, you have to segregate that into smaller parts for ease of use, for the ease of convenience, and of course it will be less error prone if you do that. So that is what is being told in very layman terms what interface segregation means. So here is the interface segregation principles definition, where it says that clients should not be forced to implement methods that they don't use. Similar to the remote example, I am a client, I am a user of this remote. I don't want that functionality to exist in my remote. When I'm handling my TV, do I need a functionality when I am handling the TV? I don't need the functionality to handle my AC or my home devices. So client should not be forced to implement methods they don't use. That is what it is trying to say. That if I have a certain interface, I will only be using that interface for whatever specific functionality that interface is supposed to do. We'll see that with another example in a while. So the idea over here is to use small and focused interfaces like we told. And to break down, if you have any large interface which is having unrelated bigger functionality, to break it down into smaller interfaces. Basically a conversion from, there's a term that we use like from fat interface to a thin interface. This is the whole point interface segregation principle is trying to say. It's okay if you have a fat interface, you have additional bloated functionality in that, it is okay, but just try to break it down, segregate it, and make multiple thinner interfaces. That's it. Now let's give a code example. What we can say is, let's say there is a message class or an interface. Simple message interface. What are the functionality? What are the methods it has? It has a functionality to send message. It has a functionality to receive message. Okay, these two. Now I have many different types of messages. I have email message, I have text or SMS message, I have voice message. So all of these are the different concrete implementations of the message interface. Email, if there's a class called email, it will try to implement the send and receive. Text will try to implement send receive. Voice will try to implement send receive. Now we know that email message or text message or SMS message have this functionality where we want to display the message to the user. So I will say void display. Okay, so this is going to display the message to the email users, to the text message users, which is fine. In case of voice message, we don't display the voice message. What do? We play the voice. So we say that, okay, let me add another function which is going to say void play. Now here's the thing, like here's the tricky part. In an interface in Java, whatever methods you're going to have, right, all your concrete implementation should be able to override that. Like they should be able to provide a proper implementation of that. Now email message and text message will provide me a correct implementation for send, receive, display. But email and text can't be played. Now voice message on the other hand, send is fine, receive is fine. They cannot be displayed but they can be played. So if I have to write like this, email versus a voice message, so I can do a send here, I can do a receive here, I can do a display here. But I cannot do a play over here. So send again here, receive over here, and I have to do a play. So one method, either the display or the play, is getting unused in each type of message, be it the voice message, the text message, or the email message. So this interface of message is having unrelated methods which is not needed. So what it says that this interface, this definition what we have written, client should not be forced to implement method they don't use. Here email and text message is forced to implement the play method. They will not implement it, they will just say unsupported operation. Like email messages can't be played. Voice will say unsupported operation for display method. I cannot display a voice message. So then what we should do? We should divide this. So now message interface will get segregated. So here, so over till now we had a violation of the interface segregation principle, that we had a fat interface which has unrelated methods, not useful. Now we are going to segregate this message into two different interfaces. Okay, I can just maybe say like a voice message. I can say text-based message. We can of course name it in a better way. We can say multimedia message also. So, I mean, we are breaking down this fat interface into thinner interfaces. Now, text-based message will be implemented by email, SMS, all sort of messages. Multimedia will be implemented by the voice message. Now, over here, what is going to happen? Text-based message will have send, it will have receive, and it will have display. These functionalities only. I have a thinner interface now. Multimedia message will have what? Send, receive, and play. So anything related to multimedia will be concerned, will be in this interface, the thin interface, and anything related to text-based information, textual information will be concentrated in this interface. So I have done a clear segregation of functionality like my principle demands. That's it. So in this way, we moved from a violation of ISP to a workaround where we converted the fat interfaces into thin interface, and thus we are able to satisfy the ISP functionality, the principle, in a correct way. Okay, so yeah, that's all about today's video on interface segregation principle. Thank you so much for watching. See you guys in the next video.